Good morning, my dear children. Today we are going to discuss about that pseudo first order reaction, integrated rate law for a zero order reaction, and one more small topic, half-life period of a reaction. These three questions we have to discuss today. Our lesson is about unit number 7, chemical kinetics. The last class we discussed about that molecularity, differences between order and molecularity, and about one of the very important question, integrated rate law for a first order reaction. It's a very important question, and about the examples of first order reactions. Now we can discuss about the pseudo first order reaction. Here, what is about the pseudo first order reaction? Pseudo answer means about that false. Okay, what is about the pseudo? Pseudo means false. So anyhow, we can discuss pseudo first order reaction. It is a first order reaction, but actually it is not a first order reaction. It may be a higher order reaction. So it follows the first order reaction. A kinetic study of the higher order reaction is difficult to follow. Here, for an example, in a study of second order reaction involving two different reactants, a simultaneous measurement of change in the concentration of both reactants is very difficult. My dear children, here we have two reactant. We have to take measurement simultaneously at the same time. Simultaneously means at the same time. Okay. The change in the concentration of the reactant, we are measuring it, is very difficult. One of the very good example is, I am taking one of the ester. The formula is about that CH3, CH3. Methyl acetate. The functional group is ester because COO group is present. COO means ester. Here the methyl acetate undergoes hydrolysis. We are adding water in the presence of an acid, sulfuric acid. So water can be split up into H plus and OH minus ion. Here this compound is split up here, that is CH3COO. CH3 split up into CH3COO and CH3. So this part, one of the H plus is adding. Then another OH part is added to the CH3. So we get the two different products. One is about that CH3COOH. That is CH3COO plus H gives CH3COOH. Acetic acid. IUPAC name. Ethanoic acid. Am I right? Ethanoic acid. Because how will you say the ethanoic acid? Two carbon is there. Two carbon means ethane. Am I right? Ethane. Here the functional group is COOH, can be say as oic acid, ethanoic acid. Next about another one compound is about that CH3OH, methyl alcohol. IUPAC name means methanol, because the suffix is oil. Am I right? Methanol. So the suffix is oil, we are adding methanol. Anyhow, that we can be discussed later. Here the ester undergoes hydrolysis. In the presence of acid, we get acetic acid, ethanoic acid, and methyl alcohol. Here what is here means two reactant. This two reactant means one is about the ester, that is methyl acetate. Another one is an water. Here the two different reactant, the simultaneous measurement of the change in the concentration of both reactant is very difficult. So what is about the pseudo first order reaction means, A second order reaction can be altered to the first order reaction. Can you understand my point? A second order reaction, this is one of the second order reaction, two reactant having second order reaction. This reactant can be altered. Altered means change. Am I right? Changing. Altered to a first order reaction by taking one of the reactant. Here having two reactant. One of the reactant is large excess. Here any one of the reactant is large excess. Such type of the reactions are called pseudo first order reaction. Pseudo first order reaction. What is about that definition? The second order reaction can be altered. We can be slightly changed, altered to a first order reaction by taking one of the reactant in large excess. Such a type of the reactions are called as pseudo first order reaction. Next, how can you write the equation part? We have to write the rate. Rate is equal to, how will you write the rate? Rate is equal to, here the K constant, you have to write the K constant, K. Then concentration of methyl acetate, CH3, COO, CH3, methyl acetate, and concentration of water. Here, two constant having, one is about that K constant, and another one is also we can be take water because we are taking the large excess. So that is also constant, two constant. Here the order is 2. Am I right? How become the order is 2? Methyl acetate is one concentration. Am I right? Water is another one concentration. So order is about 2. If the reaction is carried out with large excess of water, there is no significant change in the concentration of water during hydrolysis. So concentration of the water remains almost a constant. Concentration of water remains almost a constant. Now, rate of the reaction depends upon the concentration of methyl acetate. Now we can be define KH2O is equal to K dash. So rate can be written as rate is equal to K dash methyl acetate, CH3, COO, CH3, methyl acetate. Here rate is equal to K dash. K dash refers as it is a first order kinetics. Next, one of the very important question. Integrated rate law for a first order reaction. Integrated rate law for a first order reaction. One of the very important question. A reaction in which the rate is independent of the concentration of the reactant over a wide range of concentration is called a zero order reaction. A reaction in which the rate is independent of the concentration of the reactant over a wide range of concentration is called a zero order reaction. This type of the reaction is very rare. We can consider one of the reaction, zero order reaction, that is A gives product. How will you write the rate law? The rate law can be written as rate is equal to constant K, concentration of A naught, because it is a zero order reaction. Am I right? It is a zero order reaction. Next, How will you write? How will we can apply the rate law? That is minus of D, the concentration of A divided by dt is equal to K into 1. That is A naught, am I right? A power 0, am I right? This anything the term power 0, anything the term power 0 is equal to 1. Okay, so the A naught is equal to 1. Next, we can write we are interchanging here. Here this can be written as minus of dA is equal to K into dt. K into dt. Now, the integrated equation can be changed. The integrated equation can be changed into differential form. That we are applying limits. That is limits between, we can be say that A naught at 0 time and A at some later time. So I am writing, as per this above equation, I have minus of integrate. Here I am taking two concentration. One is about the upper concentration and another one is about the lower concentration. Upper concentration is given as a and the lower concentration is about that A naught. Next, dA is equal to K integration of dt. Integration of dt. Here lower limits and upper limits. Lower is about that time t is equal to 0. That is lower limits is 0 and higher limits, upper limits become t. T is equal to t. This can be again written as concentration of A, the lower limits A naught and upper limits A is equal to, there's a minus of, okay, minus of A, the concentration of A naught and upper limits A is equal to K into T is 0 and the power you have to write T. Don't forget that. How will it become means integration of dx is equal to x. Am I right? Integration of dx is equal to x. Integration of dA is equal to A. Integration of dA is equal to A. So, the next step, here, minus of concentration A, minus of concentration A, minus, again one more minus having, so I make it a bracket, minus A naught, that is equal to K T minus 0. Again I am modifying here. Minus of A is equal to A plus A naught is equal to A plus A naught is equal to KT. Again we can be written as A naught minus A is equal to, first I am taking A naught minus A is equal to KT. From there I am taking K I am taking, okay. So K is equal to A naught, concentration of A naught minus A divided by T. So anyhow, this equation 2 is the form of straight line. Y is equal to mx plus c, that is A is equal to, there is a concentration of A is equal to minus of KT plus A naught. Y is equal to c plus mx. That means from the equation 2, before equation 2, that is A naught minus A is equal to KT. That again one more step, if you are those who need means we can write it that on. The concentration of AB minus KT is equal to concentration of A. Next I am taking concentration of A is equal to A naught minus KT. Here this is one of the equation, that is A naught minus A is equal to KT. This equation is in the form of straight line, y is equal to mx plus c. That is y is equal to concentration A. Here C means intercept. If you are looking at the diagram, that is about that graph. Intercept C gives A naught concentration. Slope means m, that is equal to minus k. X is equal to t. Please mark it that graph also. Next one of the 2 mark question. What are the examples of zero order reaction? That is the photochemical reaction between H plus and I2. Photochemical reaction between H2 plus I2, we get the product H2 gas plus Cl2 gas gives, in the presence of sunlight, that is H2, we get hydrogen combines with chlorine to form HCl, 2HCl gaseous. The second one, decomposition of N2O on hot platinum surface. Here the formula is N2O, gaseous state. This N2O undergoes the decomposition, that is N2 gas plus half O2 gas. Next one, third example, iodination of acetone in acidic medium. Is it zero order with respect to iodine? One of the equation is about that methyl acetate CH3COCH3. This one reacts with iodine in the presence of H plus ions. We get ICH2COCH3, ICH2COCH3, and also one of the hydrogen combines with iodine, we get hydrogen iodide. Here the acetone formula is CH3COCH3. This one reacts with iodine in the presence of H plus ions. Here one of the hydrogen combines with iodine to form hydrogen iodide. The remaining product is one of an iodine is left, that will be attached to the here acetone. So one of the hydrogen is removing. So what's the remaining? 3 out of 1 means CH2. So CH2 COCH3. Here you have to write iodine, and also hydrogen combines with iodine, we get HI. Then for this above equation you have to write the rate. Rate is equal to K. K means constant. First of all you have to write the product side, that is CH3COCH3. Next one, concentration of H plus ions. Next about the next question, half-life period and period of a reaction. What is about the half-life period? Means the time required for the reactant concentration to reach 1/2 of its initial value. The time required for the reactant concentration to reach 1/2 its initial value. Here, for first order reaction, the half-life is a constant. It does not depend on the initial concentration. The rate constant for the first order reaction, already we know that one. The rate constant for the first order reaction is equal to K is equal to 2.303 divided by T log of A naught by A. Here we can change the value of T and the value of A naught. Value of A, concentration of A. T can be written as T half and the concentration of A can be written as A naught divided by 2. When we apply here, K is equal to 2.303 divided by T half. Next about that, log A naught divided by A naught by 2. So how will you write means, next step, K is equal to 2.303 divided by T half log 2. So now we can take log, am I right? We have to learn it log 2, otherwise we have to memorize it log 2. K is equal to 2.303 divided by T log. K is equal to 2.303 divided by T log. Log 2 value. Log 2 value means we must take the logarithm book. Okay, we must take the logarithm book. Please all of you take the logarithm book. A logarithm book. Log of 2 means you must take that the log book page number 2, log of 20. Okay, log of 20 means it have two characteristics value means log 20 that is a double digit number. You have to minus it 1, so we get 1 point log 20. The value is about, come to here, page number, log book page number 2, log 20 value, characteristics value, log 2 means a single digit, not a 2 digit, 2 digit. Okay, first you have to, single digit there is no log, there have no log. For 2 digit only we have the log. So log 2 means a single characteristics is about that 1, only 1 digit having, so we have to minus it to 1. So the 0 point, answer is about that 0 point, single digit. So 0 point log of 20 we have to find it. 20 means 3010. Log 20 means 3010. So 0.3010. Next we have to multiply, ordinary multiplication only. And the above equation we have to write T half also. K is equal to 2.303 into 0.3010 divided by T half. Just only for a small multiplication. 2.303 into 0.3010. Just we are multiplying, we get the value is about 0.6932. 0.6932 divided by T half. Next one, we can calculate the half-life period for the zero order reaction. The last one we discussed about that. The half-life period for the first order reaction. For the first order reaction, we discussed that one. Next, we have to discuss for the half-life period for the zero order reaction. Then rate constant K can be written as A naught, concentration of A naught minus concentration of A divided by 2. So divided by T, not 2, divided by T. Here, T is equal to, what is the value of T is equal to T half. T is equal to T half. And about the concentration of A is equal to, A naught divided by 2. From this section, we can be taken as what is about the K. K is equal to A naught minus A naught by 2 divided by T half. So we can be taken as K. K is equal to A naught divided by 2 T half. So T half is equal to A naught divided by 2K. A naught divided by 2K. Hence, in contrast to the half-life of a first order reaction, the half-life of a zero order reaction is directly proportional to the initial concentration of the reactant. This you have to learn, okay? Here, this other important area. So anyhow, today, one more question we have to discuss that one. Page number, textbook, the page number 211. Let's say evaluate yourself, question number 2. Evaluate yourself, question number 2. What's the question means? Consider the decomposition of N2O5 gas to form NO2 gas and O2 gas. At a particular instant, N2O5 disappear at the rate of 2.5 into 10 raised to minus 2 mole dm raised to minus 3 second inverse. At what rates are NO2 and O2 formed? What is the rate of the reaction? So one of the reaction, you have to write one of the decomposition reaction. N2O5 gives NO2 plus O2. These are all gaseous state. N2O5 gives NO2 plus O2. So we have to balance. First, you have to balance the equation. Here 2 nitrogen. So anyhow, oxygen is not balanced. So come to the product side, make it 4 NO2. Now come to the reactant side, 2 N2. Now the equation is balanced. Now we have to write the rate. First we have to, which are the given. We have to find, given is N2O5 is given. Am I right? So we have to write given. D, concentration of N2O5 by dt is equal to, say given 2.5 into 10 raised to minus 2 mole dm raised to minus 3 second inverse. Then at what rates are NO2 and O2 formed? Then we have to find D, concentration of NO2 by dt. You have to find it. Next, one more product, that is O2, D, concentration of O2 by dt. You have to find out. So if you wrote the equation, next you have to write the rate of the above reaction. Rate is equal to the 2 moles, so you have to write 1 by 2. That is the minus of 1 by 2 for the reactant, minus of 1 by 2. D, concentration of N2O5, concentration of D, N2O5 by dt, that is equal to, then you have to come to the product side. 1 by 4 concentration of NO2, that is D of concentration of NO2 divided by dt, that is equal to D of concentration of O2 by dt. Then First we have to compare. There is a product. First, here having two products. One is NO2 and another one is O2. Product compare with reactant. So first product is 1 by 4 d of NO2 divided by dt is equal to half into minus of d N2O5 divided by dt. So this 4 I am taking here. So we get d of NO2 divided by dt, that is equal to 4 by 2 into minus of d concentration of N2O5 divided by dt. That we can be written as 4 by 2 can be written as 2 into minus of d of N2O5 divided by dt. So that is equal to 2 into the values given N2O5, the values, that is a question given. D of N2O5 by dt is equal to, that is 2.5 into 10 raised to minus 2. Just we are multiply here. 2 into 2.5 into 10 raised to minus 2. 2 into 2.5 is equal to 5. 2 into 2.5 is equal to 5. So that is equal to 5 into 10 raised to minus 2 mole dm raised to minus 3 second inverse. So this is about the one answer. Next, the second we have to find O2 also. So next comparison, compare second product with reactant. Second product with reactant. D of O2, D of concentration of O2 by dt, D of concentration of O2 by dt is equal to half into minus of d concentration of N2O5 divided by dt, that is equal to the N2O5 value, we know that one, the value of N2O5 with the dt we know, there is half into 2.5 into 10 raised to minus 2. Next we are just dividing, we get the answer 1.25 into 10 raised to minus 2 mole dm raised to minus 3 second inverse. Next we have to write the overall rate. That is rate is equal to reactant, that is minus of 1 by 2 d N2O5 divided by dt, that is concentration of N2O5 divided by dt, that is equal to 2 product, that is 1 by 4 d of NO2 by dt, one by 4 d NO2 by dt, that is equal to other product d of O2 by dt. Then the rate half into first one is we know, that is 2.5 into 10 raised to minus 2, already that is given. For N2O5 already is given. That is equal to, for the first product, that is NO2 value, that also we find that one, 1 by 4 into 5 into 10 raised to minus 2 that is equal to, just we are cancelling 5 by 4. 5 by 4 means we know that is about 1.25. 5 4, that is we know 5 by 4. 1.25. So 1.25 into 10 raised to minus 2. So here also the rate 2.5 divided by 1, 2. 2.5 divided by 2. This also we can Cancelling we get 1.25. So total rate we can be, that is equal to 1.25 into 10 raised to minus 2 mole dm raised to minus 3 second raised to minus 1. This is answer. Okay, my dear children, next we have to write the assignment. What is about the assignment means come to the page number 215. Please all of you come to the page number 214 and 215. There is a pseudo order reaction, pseudo first order reaction, pseudo first order reaction, pseudo first order reaction. Second one, integrated rate law for a zero order reaction, integrated rate law for a zero order reaction. Third question, examples of zero order reaction, examples of zero order reaction. Fourth question, half-life period of a reaction, half-life period of the reaction. That you have to calculate that one. Half-life period for a first order reaction and also zero order reaction. First order reaction, half-life period for the first order reaction is page number 215. Half-life for a zero order reaction is page number 216. You have to write. Okay, my dear children, these are the very important question. We cannot skip this question. Okay, we have to learn thoroughly the theoretical question. Please all of you learn thoroughly and write the assignment. Okay, thank you all of you. Thank you. Have a nice day.